Hi students, I want to show you how to complete the rock identification lab. The most important place to start is by reading the background information. This is really important to not only help you through this lab, but also help you in regular life in identifying rocks, and it will help you for the test that you'll have. So as I went through, I had a highlighter and a pen, and I wrote down and highlighted things that I thought were important as I reviewed information about metamorphic and igneous and sedimentary rocks. When you get to the 6th page, it's going to give you the directions on how to complete the data table on page 7. I'm going to walk you through that part right now, okay? The first thing that I want you to notice is that in this first column here, I want you to record if it is an igneous, a sedimentary, or a metamorphic rock, okay? The lab doesn't really leave you a good place to do that, but it does tell you to do that in the directions. The next thing, the next column is going to be the color, and it's explained by number 2 here. You can just write the color of the rock. The next one is grain size, listed in number 3, but grain size is listed as the 4th column. I'm not sure why it went out of order. But then after that, you list the composition and unique features about the rock and the rock name. So the 6 rocks that you're going to use out of your lab kit, you will not use all the rocks here. Although if you want to test some of these, I think it would be awesome, and I might actually give you extra credit points if you go through and show some of those other ones that you learned. The rocks that you're going to look for are pumice, that looks like this. It's a really lightweight stone that's pretty grainy. And then there's a piece of interesting colored granite here. Not all granite are those colors. And then limestone, one of my favorites. And then you're going to come down to shale, and you'll use a piece of marble and gneiss, okay? So the answers for most of this is right here, but I don't want you to directly copy what it has. I want you to figure out some of these things for yourself. So I'm actually gonna first test, because I think it's really cool, I'm gonna show you how to do this rock, which is limestone. You can see that it is a sedimentary type of rock, but limestone is actually formed by minerals deposited out of water. A lot of those minerals are calcium. If you need more information or help identifying the rocks, you can use your rock identification key if you have this in your kit. If you do not have this in your kit, or you don't have numbers, you can kind of look at the ones that I chose, or you can test some of the other rocks in your kit, and that's okay. If you look online, there's also copies of rock identification keys there. So this rock, which is limestone, I like this one. I think that this is kind of a creamy peach tan color, maybe tan peach color. So according to the sheet though, limestone is cream and gray. To me, this one isn't gray at all. So it's okay to write a color other than what they say, because the deposits could be totally different about what the rock is made of. Remember, rocks are made up of minerals, and depending on how it came together with those minerals, it can be different. Okay, so this piece of limestone, the composition, since you probably don't know, you can look here. It says calcite. And again, on this sheet, you could also look up and see that it's made of calcite and dolomite, which is actually more accurate. And then you're going to, so the color is peach, the composition is going to be calcite and dolomite, which you might not know. But then the grain size, how big are the grains inside the rock? And I would say I could see some sparkles of grains. So this is what I would call really fine grains. Very, very small, almost like this, like a piece of salt, like very, very small. So this is a fine-grained rock. And unique features. You can look up unique features online. You can look it up in this data table and in the rock identification key. But something I wanted to show you is that you can use a light acid. Because it has calcium, it will react with acids. So here is a vinegar. If you have a fresh, new, strong vinegar at home, it would be a strong enough acid. My vinegar is kind of weak, so I'm going to use a little bit stronger of an acid. And I'm putting on my goggles, my safety goggles, and my gloves, which you should do. I'm also wearing my apron, which you probably cannot see. But if you take an acid, and like I said, I'm going to use a stronger acid. This one is hydrochloric acid solution. If I put it on the limestone, you can see that small bubbles are forming on it. That's because the limestone is getting eaten away by the hydrochloric acid. If you do a little acid test on most other rocks, it will not have that high calcium amount that limestone does, and so it won't react in the same way. Marble can actually react with acids as well, depending on how much dolomite and calcium it has in it. So I'm going to take off my goggles and things now that I'm done with that. So the unique features is that it reacts with an acid, and it kind of is a softer rock. I would write that down too. And then the rock name is limestone. So you can test any rocks in your kit and take good guesses at what they are if you don't have the rock identification key. And then on the back, I expect you to answer these questions very thoroughly. I want these ones done really well, since the majority of the information could already be found here. And maybe include a picture of yourself doing one of these little tests with vinegar or something in your lab stuff, and maybe I'll give you a few extra points for that. Okay, thank you, students, and good luck on this rock identification lab.